Hello and welcome back to the channel Understanding Concepts of Physics. So here we are with one more doubt of one of my student. So you can pause the video and just check for the questions and the given data. Let's begin. So there is this plank or something which is curved, and there is this ball which is going to roll from here, and the height of this is 10 meters. The horizontal part is 20 meters, and RS is again in symmetry to both the sides. The initial velocity is 0, so the ball is released from 0 velocity, and the coefficient of friction is only between QR, and that coefficient of friction, that is mu, is 0.2, and the distance of QR is 20 meters. So a lot of combinations of answer is given. So I'll just explain it in a very short manner, all four options. They are saying that the ball is going to get released and it is going to go here till this point, and that would be 6 meters as they are saying in the first option. And they are saying that the ball is going to go like this, and it is going to 2 meters from the ground. So this was 6 meters and this is 2 meters. And then they are saying the ball is going to come and rest in the middle, exactly in the middle, 10 meters. So this is what they are saying. So the ball is going to go like this, back to this, and back to this point, and it is going to stop. So if this everything happens what I have just said, then option D is the answer. If not, then we'll have to check which option is going to get set. Now, so my height is 10 meters, initial velocity is 0, QR is 20 meters, and coefficient of friction is 0.2. Now here the logic is important. The solution is very simple, but the logic, if you understand, then things might be straightforward. So if this ball is at this point, that means it has potential energy, that is mgh. So I would say potential energy at 10 meters height. Now as it comes down, it is not going to lose due to friction, because this part is smooth. There is no friction at this place. So here it comes at this point, and from here there is some friction, and because there is friction, there will be work done due to friction. So work done is equal to force into displacement. So this work done is done because of this surface. So the ball is going to slow down in this QR region, and it is going to climb height because it is not coming at rest at point R. It is going to climb height, and it may go at this point because there is some loss because of friction. So whatever the energy was at the starting point, this energy is slightly less. Some amount of energy is gone in doing work against friction. So I can say that potential energy at this point, let me clear this. So potential energy at this point is equal to potential energy at this point, because at both the positions the kinetic energy would be 0. It is going to stop here, it was halted at here. So potential energy at 10 meters height is equal to potential energy at 6 meters height. Now this is something I want to find. I am just assuming that it will come out to be 6 meters. Let's see. And so potential energy at this point is equal to potential energy at this point, and some work is done in this frictional part. So my first equation would go like this. Potential energy at 10 meters height is equal to potential energy at 6 meters height, and plus the work done due to friction. Now if you understand this equation, things are sorted. You have understood the entire question. Potential energy is mgh. Now this h is 10 meters, and potential energy at 6 meters is mgh dash. I am writing this as h dash, and I am trying to find this out as 6 meters. If this comes out to be 6 meters, that means the first option is correct. And the force work done due to friction is force into displacement. So work is equal to force into displacement. So that's force into displacement. mgh is as it is, mgh dash is as it is. Now friction ka basic formula is mu into n. So mu into n, that into x. Since the body is moving, mu into n is the maximum amount of friction which is going to try to hold that ball. So mgh is as it is, mgh dash is as it is. Now if there is something over here, then the gravity is acting downwards and the normal is acting upwards. So normal is equal to mg. So wherever there is a normal, I'll have put an mg over here. Now mg, mg and mg gets cut. What remains is h is equal to h dash plus mu into x. Now h is 10, h dash is something I need to get. If this comes out to be 6, I am winning. Plus a mu is 0.2, this is given, and the distance of that part where the friction is just 20. So calculation, I got h dash is equal to 6 meters. That means option 1 is a correct statement. It's a correct statement that the ball is going to go from this point and it is going to climb till 6 meters height. Now, so this option is correct, but we have a lot of options over here. So let's see for the second one. Now they are saying that the ball comes to rest second time at a height of 2 meters on PQ. So the ball is going like this, and now it is going to halt at this point till the height is 2 meters. So what I'm going to do is, because the ball was at this 6 meters, I can say that the potential energy at 6 meters height is equal to the potential energy at 2 meters height plus the amount of work done in this friction. So similar to what this equation was, I have just made another equation. Potential energy at 6 meters height is equal to potential energy at 2 meters height plus work done due to friction. Now rest is same, just calculate. This 2 meter, I am just assuming that if my answer comes out to be as 2 meters, that means option 2 is also correct. So mgh is the potential energy, mgh dash is also the potential energy, and for friction, work done is friction into displacement. So mgh as it is, mgh dash as it is, mu into n. Mu into n is nothing but the friction. Mgh as it is, mgh dash as it is, mu into normal force is mg. Because this is the block, mg is downwards, normal is upwards, so normal is equal to mg. So mgx. Now mg gets cut from each term. H is equal to h dash plus mu x. This height I am taking for 6 meters. So h dash would be equal to 0.2 times 20. This is 4. So 4 goes this side. 6 minus 4 is 2. So h dash comes out to be 2 meters. That means second option is also correct. That means the ball is going to travel from this point to 6 meters and then it is going to travel back to 2 meters. Now the third option is saying that if the ball halts at third time in the middle of QR. So in the middle of QR. So I'll try to find out this displacement. If this comes out to be as 10 meters, that means it is halting at this point. So again we'll do the same way, but the only thing is that okay, now the ball was at 2 meters. So the potential energy at 2 meters is equal to the work done in doing something. So let's say I'm assuming that this distance is x. I'm finding out x. Now since the ball is not climbing now if it would have climbed, I would have taken that as well. But because they are not saying that in the third option, I'm trying to check the third option. What my equation would become is potential energy at the 2 meters height. So it would look something like this. So potential energy at 2 meters height will be equal to the frictional force. So work done due to friction. So mgh, that is the potential energy. Work done is force into displacement. Mgh as it is. Mgh as it is. And force is mu into n, that is friction. Mgh as it is. Normal is mg. Mg gets cut. H is equal to mu into x. So I get 2, that is from 2 meters it is falling, 0.2 into x. So x comes out to be as 10 meters. So third statement is also proven to be as correct. So third statement is also correct. So now it implies that the distance up to which the ball is going to roll is at this point. Now the fourth option is ball finally comes at rest at midpoint of QR. Now if you have done 1, 2 and 3rd, then you can understand that there is no climbing height. The ball is not climbing height. I mean, you got x as equal to 10 meters. That means the ball is stopping the work done in. So it does not have that much amount of energy in order to even do the work fully. It is able to do the work only half. So it is not able to go forward to the rest of the part, and it is not able to climb the height as well. So that's why x settles at 10, and so the fourth option is also correct. Again I repeat, okay, because this ball is not able to cross this 10-meter line, it is going to finally come to rest. It is not going to move ahead any further. That's why all the options are correct, and you will find out, okay, option D is the correct answer. All statements are correct. Now, had this question not been an MCQ and had this been question in a kind of a numerical, then I would have taken a potential energy at, now this is something extra, this is not related to the MCQ. MCQ is done. Now, had this been in in a regular question wherein you are supposed to find out the values, then I would have taken as potential energy at 2 meters height this, plus work done, plus potential energy at some height h. Now if you have some time, then you can just solve this with potential energy at a height, and you will find out this height would have not come out. I mean, if you want to get a 2 over here, the x has to settle to 10. It cannot have any other value, and if there was a potential energy, you would have gotten an absurd value. So this is what it is. I mean, MCQ was way back earlier, but this is what I would have done in case if I was not having an option. So thank you very much. Follow the videos, subscribe the channel in case you are able to understand me. Thank you so much. Bye.